All right, so in this video, we're going to talk about trig ratios, and perhaps you've heard of sine, cosine, and tangent, and I'm going to define it for you now, okay? All right, so trig ratios typically apply to right triangles, and let's start with the first ratio. If I want to take the sine of an angle, let's say I'm going to take the sine of angle A. Well, by definition, the sine of angle A, right, is opposite over hypotenuse. Okay, so opposite over the hypotenuse. And if I ask you what is the hypotenuse in this right triangle, you would say the hypotenuse is always the longest side, and it's always the side that's opposite the 90-degree angle. So this is my hypotenuse. And from here on out, I'm just going to abbreviate, okay? HYP stands for hypotenuse. So in future examples or notes, I'm just going to write HYP. Okay, so if this is the definition of sine of angle A, well, when you say opposite, what do you mean? Opposite just means opposite side. So here's angle A. The opposite side would just be CB. And the hypotenuse, right, is just AC. And that's how you find the sine of angle A. This is the definition, and then this is, the specific labeled sides given on this problem, right? Okay, so, in the future, you could just write, sine of A. You could abbreviate as sine instead of writing the whole 4 letters. You could just write sine of angle A. Okay, so sine of angle A, CB over AC. Okay, what about cosine? So cosine, right, again, abbreviated COS. If I want to take the cosine of angle A, well, that's just adjacent over hypotenuse. Adjacent. I'm going to write out the full word for adjacent. And in HYP, I'm going to abbreviate. If you don't know what the word adjacent means, it just means next to. And so here's my angle A. Now, if I ask you what is the side that's adjacent to angle A, you could say, well, AC looks like it's next to angle A, right? And AB looks like it's also next to angle A. And you would be correct, but actually the hypotenuse is always the hypotenuse. And so you never use the hypotenuse as an adjacent side or an opposite side. So the adjacent side at angle A would actually be AB. And the hypotenuse is always going to be the hypotenuse, okay? So AB over AC. And of course, you could abbreviate as cosine of angle A is equal to AB over AC. Okay, the very last trig ratio is tangent. I'm going to write out the full word here for you. The tangent of angle A is by definition opposite over adjacent. Okay, so I'm going to abbreviate OPP, stands for opposite. And then adjacent, instead of writing out the whole word, I'm just going to abbreviate ADJ. Okay, opposite over adjacent is the definition. And if you take a look at your triangle, right, the opposite side of angle A is CB. And the adjacent side to angle A is AB. Okay, so if you want to abbreviate this definition, the tangent of angle A is just CB over AB. Okay. And that's pretty much it for your sine, cosine, and tangent trig ratios. You are basically, if you memorize this, right, the definition, opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, it will help you solve many trig problems, okay? And of course, the trig ratio, or the acronym that helps you memorize this, of course, is SOHCAHTOA, which has been taught through many years, I'm sure, in geometry classes. My geometry teacher taught it to me. And how does this help you memorize? Well, sine, right? S stands for sine, opposite over hypotenuse. Cosine, COS, adjacent over hypotenuse. And then tangent, of course, is opposite over adjacent. Okay, so this might be useful for you. If it, doesn't really help you and you misspell SOHCAHTOA, of course, you're going to get your trig ratios wrong. Then you don't, you know, if it doesn't work for you, that's fine. You could just memorize it using your own tricks, or just, you know, writing it down a couple of times you'll have it memorized. But, you know, this could be helpful for some of you. Keep in mind before we move on to the examples that, you know, I just took the sine, cosine, tangent of angle A, and angle A is an acute angle. You could also do the same thing for angle C. Okay, so if I ask you what is the sine, let's just quickly take the sine of angle C. Sine of angle C is opposite over hypotenuse. Well, the opposite side is AB, and the hypotenuse is, of course, still AC, right? If I say, hey, what's the cosine of angle C? Cosine, of course, is adjacent. The adjacent side would be BC over hypotenuse, which is AC. And if I say, what's the tangent of angle C? Tangent of angle C, opposite over adjacent, that's AB over AC. So you can kind of see that you can take the sine, cosine of any of these acute angles. We're not going to take the sine, cosine, tangent of angle B for now. Later on, when you guys take, you know, Math 3 in the second semester of Math 3, we'll talk about, you know, what does it mean to take the sine of 90 degrees or the cosine of 90 and the tangent of 90, okay? All right, so let's go and, you know, do a few examples here. It says find the sine of D, sine of F, cosine of D, cosine of F, tangent of D, tangent of F. And I believe in your textbook, or, you know, in the worksheets, they say, you know, write it as a fraction and then write it as a decimal. Okay, so this is just straight up application of, you know, applying the definitions. Okay, so let's figure out what the sine of D is. Sine of D, here's my angle D. And I know the definition is opposite over hypotenuse, right? The opposite side would be 4, and the hypotenuse is just 5, okay? The sine of angle F, again, you could write S-I-N, sin. Some people like to pronounce it sin. I mean, that's how you would spell it. The sine of angle F, however, is still opposite hypotenuse, but the opposite side now is 3. Hypotenuse is 5, and then so forth, okay? The cosine of angle D, cosine of angle D, you always apply the definition, right? Cosine is adjacent over hypotenuse. So the side that's adjacent, right, you're like, oh, is it 5 or is it 3? Remember, the hypotenuse is always the hypotenuse. So you never call it the adjacent side, so it has to be 3. And then over the hypotenuse, which is 5. Cosine of angle F, which is right here, adjacent would be 4. Right? And the hypotenuse, of course, is always the hypotenuse. So it's 4 over 5. And the very last trig ratio they asked us to find is tangent of angle D. Tangent of angle D is opposite over adjacent, which is 4 over 3. The opposite side is 4. The adjacent side is 3. And the tangent of angle F, again, apply the definition. Here's my angle F. The opposite side is 3, and the adjacent side is 4. So it's opposite over adjacent, which is 3 over 4. Okay, so I wrote these as fractions. I believe in your textbook it says, you know, write it as a decimal as well. So you can write this as 0.8, you know, 0.6, 0.6, 0.8, you know, 1.33, 0.75. Okay, so this first example is just applying the definitions. Remember, you can take the sine, cosine, tangent of any of these acute angles, and we're going to skip the 90 degree, you know, taking the trig ratio of 90 degrees for the purposes of this class. All right, so on the next example, you are asked to basically find the exact and approximate values of the missing variables, or the variable. And you are basically, now that you know sine, cosine, tangent, you have to figure out which trig ratio to use. And keep in mind that there could be more than one correct way, as long as you, you know, apply the definition correctly. So on this problem, right, right off the bat, they give you a 58-degree angle. You know, you can obviously solve for this, right? You know, if this is 90, this would be 90 minus 58, which is 32. So you could write it in the 32 degrees here if you want, but it's not necessary. So let's think about it. We're asked to solve for the missing variable. And based on this angle right here, right, I have a side that's adjacent, and I also have a side that's opposite, right? You would not call this a hypotenuse, right? Because the triangle is drawn differently, this is still the hypotenuse. So if it helps, right, always, you know, maybe label it to help yourself, to say, think of this as a hypotenuse. Never call it the opposite side, never call it the adjacent side. Okay, so back to what I was saying, right? You have an adjacent side, you have an opposite side, you're going to use tangent, okay? And when you take tangent, you're taking tangent of the angle, and trig is just basically ratios, right? So tangent of 58 is opposite over adjacent, which is 22 over x. Okay, so ask yourself if this makes sense, right? Tangent, I'm taking the tangent of this angle. By definition, the tangent of 58 is opposite, which is 22, over adjacent, which is x. Once you have the trig ratio correctly, right, this is just a cross multiplication problem, right? You could say x tan 58 is equal to 22. So keep in mind when I cross multiply, right, this x is out here. Don't multiply the x inside the argument. Okay, so maybe put parentheses around there. And, you know, let's say you don't have a calculator, right? It says find the exact and the approximate value. To get x by itself, right, x times tan 58 is equal to 22, you divide. X is equal to 22 divided by tan 58. So this would be the exact value. That means you understood the concept. This is the final answer. And then to get the approximate value, right, I would just enter this on my calculator. I would say, you know, 22 divided by tan of 58. Notice I'm in the radian mode, so I want to actually be in degree mode. So I'm going to change it to degree mode. And it's about 13.74. Okay, so I'll just round to the nearest 10, about 13.7. This is the approximate answer. All right, so moving on over here. We're asked to find W and V. And so let's say I want to solve for W first. Okay, so how do I know what trig ratio to use? Well, think about where W is in relationship to 71. W is next to 71, right? So there's an adjacent. And then the 5 right here, right, that is opposite of 71. So again, I'm going to be using the tangent ratio. Tangent of 71, right, is 5 over W. Ask yourself if that makes sense, right? The opposite side is 5, the adjacent side is W. And so if I want to, you know, get W by itself, just like the previous problem, right, I would do W tan 71 is equal to 5, right? If you put a 1 underneath, right, you're cross multiplying. And then to get W by itself, it's 5 over tan 71. And enter this on your calculator. 5 divided by tangent of 71 is approximately equal to 1.72. Okay, now that I have W, right, you could use Pythagorean theorem and say 1.72 squared plus 5 squared is equal to V squared, right? You already know how to use Pythagorean theorem. But you know what? Let's just practice using our trig ratios. If I want to solve for V over here, right, V is the hypotenuse, okay? So just, you know, label it to help you remember that this is the hypotenuse. This is the side that's opposite the 90-degree angle. It's the longest side. And, you know, depending on, you know, which angle do you want to use. Again, you could call this, you know, 90 minus 71, right, which is 18 degrees. If you want to use the 18 degrees, you're welcome to. I have a side that's opposite. I'm going to use the 71. I have a side that's opposite. And I also have the hypotenuse. And so if I want to figure out what V is, right, hypotenuse and opposite, the ratio that relates those two sides is sine. So I'm going to say sine of 71 is equal to opposite over hypotenuse, 5 over V. Okay, and then, you know, to get V by itself, right, you would cross multiply. V sine 71 is equal to 5, and then V is equal to 5 over sine 71. Okay, so technically you're done, right? This is the exact answer, exact. This is the approximate, exact. And then approximate, you would just divide using a calculator. So 5 divided by sine of 71, you're going to get about 5.28. I'm going to round to the nearest, I would say nearest hundredth, 5.29. Okay, now just to practice our cosine ratio, right? Let's say we wanted to solve using cosine, you could, okay? If you want to solve this problem using cosine, you would have to use the 18 degrees, right? So if I say, hey, cosine of 18, well, by definition, cosine is adjacent over hypotenuse, right? So that would be 5 over v. And you would say v cosine of 18 is equal to 5. V is equal to 5 over cosine of 18. If you enter this on your calculator, you're going to get the same thing. You're going to get 5.29. Okay, so 5.29 if you want to use the 18 degree. Okay, so that's just a quick review of cosine, sine, and tangent. Let's do one more problem here. This time they have 49 degrees. They have a hypotenuse that they want us to solve for. And they have a side that's opposite of the 49 degrees, right? So in this one, I would use sine of 49 is, and actually we'll call this way 1. Sine of 49 is equal to opposite over hypotenuse, okay? 11 over x. Again, you would cross multiply and solve. X sine 49 is equal to 11, and x is equal to 11 over sine 49, which approximately equals to 14.5. Say 14.58. Okay, so that's way 1, right? Now, if you want, right, you don't have to use sine over here. If you quickly figure out what this angle is, right, this would just be 90 minus 49, which is 41. If you want, you could say, hey, I want to take the cosine of 41 degrees, right? Cosine of 41 is adjacent over hypotenuse, 11 over x. And you'll get the exact same thing. Okay, so x is equal to 11 over cosine of 41, which is also going to give you 14.58. All right, so that's a quick, few examples on using sine, cosine, tangent. As you can tell, it's fairly straightforward if you memorize the definition. And in the next video, I'm going to talk about, angle of elevation, angle of depression.